I guess I'll show you guys my dragon here. He's kind of colorful. Let's see. There we go. And so here's my dragon, and he is a fire breather. I have a couple of dragons, but this one's the fire breather. So in order to feed a dragon first thing in the morning, you need a dragon feeding device, otherwise known as a funnel. And dragon food looks a lot like cornstarch. So we're gonna add. I'm gonna walk over here. We're gonna add a little bit of our cornstarch here to our dragon, and there we go. Maybe feed him a little bit more. I know he's like really hungry. It's already 11 o'clock. He hasn't gotten much food. There we go. That'll be pretty good, about like so. All right, set the device aside. Set the food aside here. Now, dragons, when they get cranky, they kind of breathe fire, right? Well, now that he's fueled up, he's going to be able to breathe a little bit of fire. So, what better way to help him start up than with a torch? Now, this is not something you want to try at home. Leave it to us professionals here in a professional setting. Professionals. All right, here we go. And on the count of 3, we're going to add a little bit of oxygen to our dragon here. Are you guys ready? Count down with me at home from 5. 5, 4, 3, 2, 1. Woo! Oh, he's out of fire already. Now, you guys, we saw that fire, that worked really well just now. But one thing that I find is really cool is with this online world, we now have a way to maybe slow that down. If you didn't catch that, I'm going to show you it in slow-mo. Are you guys ready for this? Let's see. So what you just saw was a little bit from our Frio the Dragon show, our summer reading program show, the online version. That's just one experiment from it. There's a whole story that goes along with that for 45 minutes. And it's a lot of fun, and it's really engaging for the kids to be able to see this. And we find that with the videos, it's actually really cool because we can kind of do some extra things that we don't get to normally do. You can't really take a slow-mo video while you're out at a location. And we can do some pretty large things like that really, like, you can't, like I said, do, like, that don't travel well, I guess. And maybe doing something like that in a library isn't always the safest thing to do either. Now, I'm glad you guys joined us again today here. And feel free, Kathy is moderating with us right now. I know you can't see her right now, but she is monitoring. She's listening in. And so if you guys have any questions and stuff, feel free to go ahead and type those in the chat, and she will be able to get back to you on all of that as well. So let's see. I also kind of wanted to show you guys a couple of the other things that we do. So obviously we do some of our shows, demos like this live, but we also have things like we have our camps. One of ours is like the NASA camp. Earlier I had the dragon food sitting next to a rocket. You know, it's a good day when you have dragon food and a rocket sitting next together, right? Now, this is a rocket that comes from our camps, our NASA camp. And this is something that we actually build online with the kids. They get, with the camps, they get things that are either sent to the location for them to pick up, or we can even send it directly to them, I believe. So our rocket comes looking like this, and we actually spend the time and build this rocket step by step with the kids. And hopefully they get one like this. Unfortunately, it makes it really tough for us to launch one of these, but we also are, you know, we have a couple of videos in store to show those as well. And then hopefully once weather is great, then maybe we can schedule something that we can all go out and see a rocket launch at some point. So anyway, there's a little bit about our rockets there and everything with that. We also do, just like we have in the past, we've done booth activities where we have somebody come out and set up a booth, and for like a science night or for a day at a school or wherever, We'll have like a booth for an hour. The kids come in 15-minute increments and things and rotate. And that's something we can still offer. In fact, one of ours that we have is our dry ice booth. It would help if I had my bucket of dry ice here. Give me 1 second. I'm going to run and grab some ice. Talk amongst yourselves. Wow, I had to run all the way to the store really quick. I'm so glad that they had dry ice today. So, with just a demonstration of one of our booths here. Give me 1 second. Oh, there we go. Huh. Had to go to the hardware store and get some gloves and a hammer as well. There we go. All right. So, we have to be safe. We have to wear gloves in order to handle our dry ice. It's really neat. We have a whole bunch of, again, different things that we can do with dry ice and that we show with dry ice. But this is one of my favorite ones here. This is what we call our bubble shower. And so we're going to start off, we're going to take a couple pieces of dry ice, which look something, I know I'm going to get a close-up here for you guys here. There we go. So our chunk of dry ice looks something like this. It's it's hard. It's not, it's not dripping water or anything. So that's how we know it's dry ice. It's made from frozen. Well, let me ask you guys, because this is supposed to be interactive. So does anybody know what is dry ice made out of? I know, pop quiz, first thing in the morning. I'm sorry. It's carbon dioxide. Oh, there you go. Awesome. Thank you, Gretchen. I love that. Yes, I love the writing. That's perfect. Awesome. So we're going to add a little bit of our dry ice now. We're going to add it over here to, there we go. That's the one I'm looking for. We're going to add a couple pieces here. There we go. And another thing that's really neat about dry ice is the fact that it's frozen carbon dioxide, just like Gretchen said here. So frozen carbon dioxide freezes at 109 degrees below 0 Fahrenheit. So we're going to add ourselves a little bit of warm water here to help that turn back into a gas really quickly, because what we breathe out is carbon dioxide. We can't see it. It's not frozen, right? So when we breathe out carbon dioxide, it's a gas. So what we're doing right now is we are turning this solid straight into a gas. Now, I'm sure you guys have all seen a bunch of stuff with this dry ice, but this is pretty fancy. I really like this thing. So we're going to add that. And since it's a shower, we need a shower head, right? So here's the shower head. Oh, perfect. And then the last here, we'll move this over here so you can kind of see against the black background a little bit better. And this fog is, if you've never felt dry ice fog, I'm going to tell you, it's very light. It's a little bit chilly. And it's almost like holding a cloud, because basically that's what's happening right now. This cooler air is allowing the moisture in the air, water molecules to condense, and it's causing these little droplets, which we see as fog. So the last thing we need in order to take a shower, right, is some shampoo. So I have some baby shampoo here in a little cup, and so we're going to add ourselves a little bit of our baby shampoo. And what are some things that we can do? Well, let me ask you this first. What do you think is going to happen once we add our shampoo and our water to this? We're going to experiment. Here we go. You ready? So you can see we've got our egg here. Now, frozen bubbles! Yes! And now, that is what's really neat about this. I'm going to switch views here for you so you can see this up a little bit closer. So, what you can see here happening, our fog is filling up. Whoa! That thing launched. We can see if we can get it to land on my arm. Here we go. Sometimes different materials look different ways. So, any guesses as to why maybe those balloons are popping, or why those bubbles are popping? Any ideas? Anybody? I know, science quiz. You would think that when you hold it in your hand, you'd be able to hold it in your hand. But what's happening here is the soap in there, it's the same reason we like to wash our hands. The soap in there is reacting with the oils and the things on your hand, and it's causing the soap film there to break down. And then that allows all that frozen carbon dioxide, or I guess the gaseous carbon dioxide now to come out. And we see that as kind of like this balloon or bubble explosion. Now, I'm going to set this thing aside here. I kind of want to do one more experiment for you guys here, and then open it up to questions and answers too. You guys can feel free to ask questions. That's the cool thing about this, making it interactive. You can feel free, like I said, ask questions and things. There is actually, if you go, I don't know how familiar you are with Zoom, but if you click on the participants tab down at the very bottom, you will have things that show up that give you different answers. So you can use like a yes or a no. It's going to be down at the bottom of the window. And then there's go faster, go slower, and there's even more. There's thumbs ups, there's thumbs downs, there's clappings, there's even a coffee mug and I don't know why you would need a coffee mug, but there's one there. So you can feel free if you have a question about something. There's also, I thought there was a raise hand on there, but you can do anything to flag my attention there. Like maybe the clap thing would be great because then I can see if you have a question. And then that way I can answer those for you. All right, now, or the coffee thing would be great. If you have a question, toast me with some coffee. All right, so one last demonstration here, like I said, because I have to end all my demonstrations with a bang. I think it would be fantastic to set up my favorite experiment of them all. And this is by far the funnest because it's two experiments for the price of one. We're going to move our rocket here, actually. All right, so the first thing we're going to need to do in order to do this is we're going to need some, I know this looks like a trash heap back here. It's really a science experiment, I promise. We're going to add some aluminum foil here to our flask. Now, this aluminum foil is going to help us to get a chemical reaction. You guys are probably the oldest group of scientists that I've ever done this demonstration for. So what's a chemical reaction? I think you guys would be able to answer this for me. Anybody have any idea what's a chemical reaction? All right. Swoosh those around a little bit. There we go. I love it. Yes, change in molecular structure. That's the most grown-up answer I've ever gotten. Yeah, that's fantastic. It is. And in fact, you can even simplify it and think of it as like it's a change of things that is a little, or you can't separate again, right? So just now, molecular structure, I love that. That's like the best way to say it. So just now we have our water and aluminum foil in this. Can we separate them? Well, yeah, of course we can. We can filter it out. We can set this outside and let the water evaporate. We've separated the two, and then we still have water and aluminum foil, right? So we're going to add one more thing to this to get our reaction really started. And in fact, I'm going to go ahead and goggle up for this part. Excuse my hair. There we go. And we're going to throw a glove on here because this stuff, it's a little bit dangerous. This is something called sodium hydroxide. It's a really, really strong base, which is kind of the opposite of an acid. We'll talk about that later on. So we're going to add a little bit of that to here. Also, don't drink it or eat it because it's poison. So we're going to add this. And this is going to start our chemical reaction inside of our flask here. We'll eyeball that. That was looking pretty good about there. Again, this is not something that you're going to want to try at home. I mean, you might want to. Please don't try this at home. All right, so we're going to swoosh that around a little bit because that's going to start getting us all those gases that we're making inside of this. This is another way we can tell we're getting a chemical reaction now. This flask is getting hot. Actually, it's pretty warm already. And you can see the balloon is filling up. So we're having some changes going on to our molecular structures in here. Does anybody have any idea what the substance is or what this gas might be that we're putting into this balloon? Go ahead and make your guesses now. I'm not going to tell you yet. That's getting to be a giant balloon. All right. Oh, no. Woo. Well, this is going to be a fun one. You can see we've got some hot gases coming out of there. We're going to go ahead and pull that off of there to let it keep airing out. All right. So tie this one off. All right, I'm not seeing any guesses yet in the chat. Let's see. Does anybody? Well, let's check this thing first. That's a little warm. We're gonna put on a glove here. We're gonna move this so that way I can see you. Now, this here. Let's do a test. If I let go, we're going to see which direction this balloon goes. And that's going to tell us a little bit about the gas that might be inside of this. Here we go. 1, 2, 3. So it's floating, which tells us that this is less dense than air. So it's wanting to float. So there's a couple of things. Helium, I love it. That's a really, really, really good guess. There's another one that's just as light as helium, maybe a little bit lighter. And it's even, it's the first element on our chart of elements, our periodic table, I guess. It's number 1 up there. It's hydrogen. We just filled this thing with hydrogen. Now, you know anything about hydrogen? It's not happy being alone the way it is. It wants to combine with other things. And when it does so quite, well, should we say energetically, right? So this, I have to use a little bit of this stuff here, some duct tape. By the way, Star Wars fans, duct tape is a lot like the Force. It has a light side, it has a dark side, and it holds the universe together. All right, there we go. Take our hydrogen balloon now. This is, again, something you're not going to want to try at home. There we go. So we had our first reaction. We had our first chemical reaction. We made our hydrogen and a bunch of other stuff that's kind of left inside of here. It's looking pretty gross. That's another way you know we had a chemical reaction or a chemical change. The color is changed here. Now, we're going to switch cameras again because I don't want to make this thing blow up right in my face. So we're going to set this right over here, back to our dragon. Hey, Mr. Dragon. All right, now we're going to add a little bit of fire here. And now, there we go. Are you guys ready? Count down with me at home. Here we go. 3, 2, 1. Woo! That, man, I felt that one. That one did. That certainly blew up with a little bit of force there. Now, again, this is a great way. You could see that really, really close just now. And we were safe about the whole thing, too, because you're on the other side of a camera. So we can kind of get close with these things. It makes it pretty fun. So let's see this thing in slow motion and see what that really looks like. Here we go. Awesome. But like I said, if you have any questions too, you can feel free to give us a phone call. Our number is 913-888-8877. Well, thanks, guys. Take care. You guys have a great day, all right?